Today, I wanted to really quickly give you an update on what I have today. As you have been aware, I've been trying to provide my graduate level course on machine learning, deep learning, and large language models publicly to everyone. And this is an ongoing project. I have had a lot of progress right now. So most of the lectures, they're actually uploaded in my website. The address is courses.brianjalian.com. I'll try to add this in the caption as well. So the way this works is, so you actually go to my website and you would see something like a digital book. And then this is kind of already have different chapters and different modules. Some of the modules are still under basically development. They still have contents, but maybe they don't have the video or something. So we'll basically keep updating this digital book. Right now, for example, you could definitely take a look at module 1 and 2. I think the module 1 is just like the introduction, and you probably have already seen some of those YouTube videos in my channel. And for every module, there would be associated notebook, and you can basically run that notebook without any need to have a GPU or setting up your environment. Everything can be run over basically Google. So this is a self-contained course, a really self-contained course where there is materials, there is videos, there is compute, and it's an interactive course where you can actually learn everything from beginning of machine learning to deep learning and then to large language model. That's the idea. Let's take a look at module 2. So as you see, there's overview. If there would be some lecture materials, such as the presentation slide that we're using or some extra notes, it would be provided here. So you can just press and then you would be able to see the lecture notes or the slide that's on the video. And then the actual videos are segmented. For example, this particular lecture has about 5 videos, so you can actually watch them. So you just press here.
Welcome to the module on training simple ML algorithm.
Then you can actually make it full screen. And the videos, usually they also have subtitles. So, and then you can go back to the original size.
And training on adapt.
So these are the videos. So you can study these things and watch the videos or study the actual slide decks. And after that is associated with a notebook. So the notebook is essentially a computable Python code that could be run over a software called Jupyter. So usually you have to set this up locally, but instead of that, this is designed in a way that you can actually press and then run it in Google Colab, which is a product that gives you compute and allows you to kind of run notebooks. So I have already connected my Google Colab. If you weren't, you just press here connect, and there are different ways you can work with it. For some of the notebooks, you don't need GPU. For the notebooks that you have GPU, you can actually go here and then change sort of resources. For example, right now we have about 13 gigabytes of RAM and about 100 gigabytes. If we wanted to change the session or something, we can change the session. If you wanted to change from CPU to GPU, which you don't need GPU, you can go and change the runtime. Right now we're operating on CPU, but you can go get T4. I'm going to cancel it right now because it doesn't need, but essentially what I'm trying to say is you would be able to run codes on GPU as well here. So once your environment is up and running, so you can actually read the code. Not every block of codes are needed. And for example, this block is coming from previous sort of check marking of the local compute. That's really not needed. So you need to actually read things. Also, do not run the images because these images are already integrated in the notebook. So if you run it, because we have not provided in the website, it's not able to fetch it. So it will just get an error. So this is an example, right? Because it doesn't have it in the website. So do not touch those things. So this is, you can go ahead and then read explanations, and then you need to run the important codes. So this is, for example, a good code here that you can run. Now, if in these important codes, if you get some error, there you can actually use Gemini that's integrated in Google to kind of figure out what's wrong. Let's run this part. So we're able to get the data live from UCI. Sometimes you might have some issues with the data sets because some of the codes might assume that you have the data already in Google Colab. If that's the case, you should actually go and then figure out how to get the data set, and then you can upload the data set here manually, and then your Google Colab would have it. So you can treat this as a little cloud computer, and then it will do the things for you. Let's just plot these things. The iris data set. Let's just have a perceptron. Looks like we got some error here. For example, here we can use the explain error functionality of Gemini and see what has gone wrong. I'm not going to get into debugging this, but that's an example of there could be some problems, right? And then Gemini could actually help you and then tell you what's wrong, and then you can learn. So the idea is you can basically work with this interactive, basically a setup in which you can learn and then debug code. So you don't want it to just back and forth press everything and then just not learn things. So it's good to cut sometimes error. All right, so for example, it seems here, if you read this error, there's some mismatch. So let's see whether it can fix the error or it can be a start of us learning something. So I'm going to press fix the error. So let's see if we can do that. All right, so now it's suggesting me that this particular line of code, self.b np float, that's not the way to do it, and it's recommending me to use np.float64 because this numpy library has been updated. So I would basically accept and run it. All right, and now I go back and basically run this piece of code that was generating some error for me. Let's see if it works. There you go. So that's the whole idea. So essentially, that's how you actually able to learn. And we actually intentionally left some of these issues so the codes are not polished. But the idea is like you can work and basically see if there's some version mismatch or anything wrong with the code, and then correct it and learn from Gemini as your tutor that helps you learn things. And then you can always also, once you have done all these things, maybe you want to save this code. So you can copy this to your drive. You can basically save it, or basically save a copy in your GitHub or however you want, or you can even download it locally as well. So remember, if you do all those things and you do not save it, it's not going to be saved. The version that's in the website is not the version that you're working on. Good luck.